Today's lesson will focus on area. The objective of today's lesson is to find the area of irregular shapes using breaking apart. This is the third lesson in topic 14 of Envision. Let's begin with problem solving. Miss Wilson's desk is shaped like an L. The length of each side is shown below in feet. Find the area of the desk surface without counting squares. Okay. Now, normally, if I had a regular figure, a rectangle, or a square, then I could use the formula area equals length times width. But usually, figures that I need to find the area for are not rectangles or squares. Many times, they are irregular figures that I need to find the space inside or the area inside. And in this case, it's the surface of Miss Wilson's desk. So, since I cannot use my formula for area equals length times width, I can use the strategy of breaking apart. What I will do is I will break apart the surface of this desk. So I'm going to break apart this figure so that I have regular figures that I can use the formula with. And now you see that I have two regular figures. I have a square and a rectangle that I can use length times width to find the area. So I know that this side is 3 feet and the other side is 3 feet. So now I can use length times width, which is 3 times 3, to find that the area inside is 9 feet squared, or 9 square feet. Now I have a regular figure on the top, a rectangle. And I can use length times width to also find the area inside this figure. I know that this side is 3 and the long side is 7. So 3 times 7 equals 21 feet. So I can add the two products of the two figures together to get the total area. 21 plus 9 is 30 feet, or 30 square feet. So that is the surface of Miss Wilson's desk. So we just found the area of this surface using breaking apart. Let's try another one. The winter PTO is covering the floor of the greenhouse with artificial grass carpet. The shape of the area that is being covered is shown below in square feet. How many square feet of carpet does the PTO need to buy to cover the floor? I can use breaking apart to help me solve this problem. If I look at my figure, I can break it right along this line to make regular figures. Now I have a rectangle on both sides and a rectangle on the bottom. So I just turned my irregular figure into 3 regular figures, 3 rectangles. So I'm going to shade this rectangle green. And I know this side is 3 feet. And this long side, it tells me, is 4 feet. So 3 times 4 equals 12. 12 square feet. I know that this other rectangle is exactly the same. This says 4 and this is 3. So this is also 12 square feet. So I just found the area of these 2 figures using length times width. Now I can find the area of this bottom rectangle using length times width. So this is 4 and this is 8. And because I know my math facts, I know that 4 times 8 is 32. Feet squared. Now I can put together 12 and 12 and I get 24. And I add in 32. 4 and 2 is 6 and 3 and 2 is 5. So 5 square feet. And that's how you find the area of an irregular figure using breaking apart, finding the area of the smaller figures and then adding them together. So let's try a couple more. Please don't pay attention to the numbers. We're just going to be looking at the figures and finding the area. I see in the first figure there's an L. If I break it apart, I will end up with 2 smaller rectangles. This side has 2 units. And this longer side has 3 units. So I know that 3 times 2 is 6. And now I'm looking at my pink rectangle. The long side has 1, 2, 3, 4, 5 units, and the short side is 2 units. So if I use the formula for area, 5 times 2, it's 10. And now I need to add my 10 units and my 6 units. And I get 16 square units. And that's how I use breaking apart. Let's try another one. Now this one is measured in centimeters. I can break it apart right across this line, and I would get a big square and I'll get a rectangle. And what I like is that this side tells me it's 3 and the top side is 4. So 4 times 3 equals 12 centimeters squared. So we just found the area for this top figure, the top rectangle. And now we're going to find the area for this bottom part, this bottom square. Now, this side is not 9. Even though there is a 9 over here, that means this whole side is 9. But we just broke it apart right where that line is. And I know that this pink section is 3, which means I have to take 3 away from this 9. So that means that the green section is 6. Because if I put the green section together, which is 6, and 3 more, then I get this 9. So this side, which is the green side, is 6, and this short side is 6. So 6 and 6 is 36. 36 centimeters squared. Now I will put those together. I'll put together 12 and 36. And that's how you use breaking apart to find the area of an irregular figure. So let's try measuring to the nearest centimeter, finding the area of the following. This short side is 1, and then this other small side is 1. And I'm going to break it apart right there. And I'm going to end up with a square, which means this is 1 times 1. I measured this side and this side. 1 times 1 equals 1. So this is 1. And now I see that I have another small side down here. That's 1. And this short side is also 1. So 1 times 1 equals 1. So this is also 1. Which leaves me the long rectangle in the middle. That's the long section is 4.5, 4.5. And this short section is 1. This is 1 right here. And together those two make 2. So I know that this section is 1 right there. So I'm going to multiply this long side, which is 4.5, times this short side, which is 1, which is 4.5. And now I'm going to add those together. So I have 1 plus 1, which is 2. Don't forget, on a whole number 2, I have my decimal is right behind it. And now I'm going to add my 4.5. And the total area of this irregular figure is 6.5 centimeters squared. Let's try one more. This is 1. And then I'm going to cut it off right there. And this short side is also 1. So that's 1 over here on this side. This side is 1. So 1 times 1 is 1. And now that leaves me with the regular figure above. And that's 4.5, 4.5, and this is about 2. So I have to multiply 4.5 times 2. 2 times 5 is 10. 2 times 4 is 8 plus 1 is 9. If I have one decimal, that's one decimal place, my answer is going to have one decimal place. And I'm not done because I need to add the green section, which is 1. And I know that on a whole number, the decimal is behind it, one space to the right. So if I add 10 centimeters squared, I can just write it like this. And that's how I use breaking apart. Now it's your turn. You will need to find the area of these figures using breaking apart. And of course, if you have any questions or comments, please put those in box 4. That's all for now.